Hi everyone, welcome back. So, in the last video, I have explained what are the steps to be considered while building and logistic regression. So, let's start with the extract data. So, I'm having the file social network ads. I will copy this path, and already I have copied. So, I have to import pandas for reading the data as pd data equals to pd dot read csv. Within this, I will pass the file folder path. Data dot head will give first five rows. If I run this, I will having the data frame having the column names is estimated salary and purchased. So in the purchased, I have the category value. If you see here 000, these are the category value, means either contains 0 or 1. Let's see what I am telling. Data dot ilog all the columns till considered as 15 for minus 1. So if you see here, I found only one, and only 0 and 1 are there in the category in the purchased, which is the target variable. Target variable is nothing but the dependent variable y. Okay, so in experimental data analysis, as you know, I have to check whether it contains null values or not. Is null dot sum. Okay, no null values, so I will check the information about data frame. Data dot info. Okay, integer, no object. Data dot describe. I will check the description of the data frame. Done. So let's go for feature extraction. So in here I'm having the three columns where the purchased is my y dependent variable, and age and salary, estimated salary is my uh, independent variable. I will consider x, which contains data frame with index location starting from 0 to last all the rows for all the columns except the final one. Dot values, which converts this data frame into numpy 2D. Done. Same way for the target variable, dependent variable, I will consider only last one. So index location for data frame data, I will consider all the rows for the last column and convert it into numpy dot values. Done. So I will check what are the values. Print x. If you see here, it is in the 2D array. This is my age. This is my estimated salary. Let's see. Print y. I have to get the predicted. If you see here, only 0 1 are there. So this is the categorical value. Now, first step of the model building. Next to go for the model building. In the model building, my first step is to split the data into two halves. One is training set, another one is testing set. From sklearn dot model selection, import train test split. I will take four variables: x train, x test, y train, y test. So these four values will come from this function train test split, where I will pass the data x comma y and telling that I need training set of 70% of the data to be trained. So for that, I will use test set equals to 0.3. So 30% of the test data and 70% of training data with a random state of 42. You can give like this. Let's see what is the shape of the X and Y training set and test set. Train shape, train data shape is X train dot shape. I will copy this. I think shape will not work because I have converted it to the value. So for now, let's comment it. X train shape and Y train shape. Y train shape. The same way for the testing also. X test and test. X test and Y test. So I have to execute this once again. If I run this, I found 280 and 120. This is the shape of the training set and data set. After this, I will use the standard scalar for arranging them in the proper dimension from sklearn dot reprocessing import standard scalar. I will take the reference as the way in the within the variable using the variable standard scalar sc. I will convert. I will arrange the dimension of x train so that x sc dot fit transfer x train. For the x test also, sc dot transfer x test. So till now what I have done, I have prepared the data and using standard scalar, I have standardized the dimension. Next, my model building. So I have to train the model. For the training the logistic regression model from scalene dot linear model, I will import logistic regression. I will take a variable for logistic regression. Now I will fit the training data set model dot fit x train comma y train. If I done this, logistic regression model has been trained. Now we have to start with the model evaluation. So in the logistic regression, we can use the metrics of you for accuracy score, F1 score, R2 score, mean square error, root mean square error, confusion matrix has. So for that, first step is my from scalar dot metrics import R2 score, F1 score, mean absolute error, squared error, and confusion matrix. For normal mathematical calculations, I will import numpy. Import numpy as np. So test score test underscore sc equals to model dot score x test comma y test. Train score, train underscore SC equals to model dot score x underscore train comma y underscore train. Print testing score is test SC. Same way, print training score is my train SC, and I will find the R2 score, R2S. So before that, okay, before this, I have to get the Y predict. So this is my testing score, and the training score is found 85%, and training set is 82%. Okay, it is more than 80%. Now Y predict equals to model dot predict. So I am predicting values for X test using the logistic model. So in this model, I have the logistic regression, and I am predicting for X test, and I will print Y pred. So this is my predicted values. So for the on this, I will find R2 score, F1 score, mean absolute, mean square, and confusion matrix. So first step is R2 score equals to R2 score for Y test and Y predict. Mean absolute error. Mean absolute error between Y test, comma Y predict. Mean squared error MSC variable which stores the value of mean squared error between the dataset Y test and Y predict. Root mean square, which is the square root of np dot sqrt, the square root of MSC. I will print, and one more left is F1 score. F1S equals to F1 score for Y test and Y predict. So I'm finding the R2 score, mean absolute, squared error, root mean square, and F1 score between the raw output and expected output. Okay. Actually, this is my expected raw output, and this is my predicted output. So, what is the difference? If there is a small difference, then the accuracy and prediction model is good. Okay. So, I will print those values. R2 score, R2S, print mean absolute error, MAE, MAE, print MSC, mean squared error, MSC, print root mean square, RMC, found by RMC variable, print F1 score, F1 score. If I run this, I found all the values. So mean absolute error, square error is less than 2, and root mean square is something around 0.3. It is okay, okay. Why it is coming like this? F1 score. Okay, I found F1S. It should be F1S. If I run this again, okay, nice. Now I will build a confusion matrix. CM variable confusion matrix. I will pass the dataset, actual dataset and predicted dataset. I will print CM. So this is the 2D matrix which contains true positive, true negative, and false positive. And now let's visualize the results that I have done till now. For this, I will import matplotlib dot py plot as plt. Import import numpy as np from matplotlib dot colors. Import listed color map. So except I will take except equals to sc dot inverse transform of x trait and y underscore cell equals to y train. Now I will take two variables x1 x2 which is written by np dot mesh grid will pass np dot arrange. I will have three values here in the range: start, stop, and step. Start equals to stop is equals to step. Okay. Same way, I will have one more: start, stop, step. So in the start, I will have except. I will consider all rows for 0 where minimum value minus 1 to consider the initial one. Paste except. I will consider all the rows for the 0th column dot maximum value plus 10 the step size say 0.25. In the np.arrange start except, I will consider all the rows for the new column next column which is 1 and the stop dot minimum value minus 1000 which is the salary column. The stop will be I will consider all the rows for the next column dot maximum value plus 1000 step size same 0.25. You can take anything till now. Okay, the machinery. Now I will plot this for plt dot counter f for x1 x2 where I will model dot predict sc dot transform np dot array where it takes two x1 dot ravel comma x2 dot ravel. I will use the transpose for this sc transform and I will reshape it to x1 dot shape x1 dot shape comma something dot. So now I will use alpha equals to 0.75 and C map, which has the distilled color map, and I will tell to plot with the color red and green. Okay, so here I will have the for I comma j in u numerate np dot uni y set, where I will get 0 or 1. Now I will plot this as a scatter plot for x set, where my y set equals to 0, 1 for 0th column, and x set where y set equals to I for next column, where my color will be listed color map red and green, red and green with index I. So it will map for which 0 for which 1, it will plot that those colors for that only. So label will be J. PLT dot present for plotting the label for the final plot PLT dot show. If you are interested, you can plot X label with salary and PLT dot Y label is, you can add title PLT dot title as logistic regression. Logistic regression. So if I run this, it will take around 3 minutes to plot everything. First, it will plot the counter F, then scatter plot. Means on the total colored plot, it will give you the colored image, colored scatter plot, which differentiates between 0 and 1. So let's wait what will be the output. Let's check. So just a small recap once again. So first step, I have extracted the data, and after the extracting data, I have explained the data, what the data is about. So I checked whether the null values or not, then information, and then I have checked whether the data is within the integer or float type, and description, and I have extracted the features in x and y variable, and I have printed, and you can also change it to dot values as well. And if I change it to dot value, then you no need to write this print text train shape and y train shape, x test shape, y test shape. And here I'm having the standard scalar, and this is the logistic regression. And then in the evaluation matrix, I have you found the score, testing score and training score for the whitest and white trend, and then using the prediction values I have found the R2 score, F1 score, mean absolute squared error, and confusion matrix, and these are the evaluation metrics. And I found that there is an error less than 2.2, and this is my confusion matrix, which contains true value and false values for positive and negative. And after visualizing the results, this is what the plot. So okay, this should be the age and this should be the salary. So I have to change this as to y, and this has to be x. I think it should not throw the error. If it throws the error, you have to run all. Let's wait and check whether what will the output, the plot. And I think you can also remove this warnings with import warnings dot import warnings and warnings dot filter warnings ignore. Now it is okay. This is the final output for the logistic regression. That's it from my end. Thank you. If you have any doubts, let me know.